Hello. Hey, hi all. Thank you for attending our talk today. I'm Sudershan. Today I'll be presenting our work towards understanding context from activity patterns. Today, uh, IoT sensing approaches today are like on the high level looks at like sensing data, data from the sensors, and then tries to provide activity. There's a whole entire vision of the human activity recognition. Uh, all of these activities are atomic in nature, but the context itself provides higher level meaning. For example, when a person is talking, we need to associate it with the context such as a meeting. Similarly, when a person is in a phone call, we need to understand this activity pattern such as like phone ring and then activity such as talking happening. Other contexts such as working and exercising requires these atomic activities to be detected in the first place. All of these contexts over a period of time can indicate many metrics of working for long hours of time, or like if you're skipping a meal, which could indicate information for different applications such as understanding productivity, stress, or like health itself. Our work focuses on this activity to context recognition without worrying about any of the agnostic to any of the sensing modalities itself. Can we just take activities and then use it to predict context? That's our goal. There are several approaches that have looked at this type of work. One of them is like looking at the data-driven temporal approaches, looking at these activities' atomic values, and then creating a temporal clustering, and then providing a context pattern from them. There's other approach that has been available right now is towards providing rules between activities, location, and then emotion, and then associating with a particular context itself. However, activities are very complex in nature. For example, like for a context such as on a phone call to be detected, there needs to be a phone ring that has to happen in the first place, and then the talking activity needs to happen. In addition, people are in general, we are in different contexts. We're switching between multiple contexts. We're eating, we are working, we are doing multiple activities at the same time. So how do we reliably detect context in the real world, right? Towards this goal, we build this hybrid approach where we build a custom ontological pipeline where we define a set of rules between activities to a particular context with in definition of like time into consideration, and then provide these instantaneous activities. For activities which are temporal in nature, we cluster these activities, and then using our ontology, we label these clusters. So let's look at the ontology in a high-level view. All the activities are instances of the high-level activity class. We've defined time period stamps. So every activity, for example, a phone call would be associated with a time period, or it has to be defined with a particular rule that a phone call has to be happening after the talking has happening. All of these activities are towards this particular context class, and then each of these contexts, such as on a phone call, is defined as particular object property, such as has activity only or intersection of, which is defined by the OWL vocabulary. OWL is basically a graphical representation language, and we use that. Eventually, all the activities that come up, we use our OWL reasoner. We then allow the Sparkle queries, which allows us to do multiple activity queries, and then from the ontology itself, and then provides context. So now Prasoon is going to talk about the temporal clustering pipeline.
So we are working. Hi, everyone. Okay, so with ontology, we can actually get context out of a sequence of activities and parallel activities. But in real life, things are a little bit more complicated. Why you ask? One is activities are usually interleaved in nature, and at the same time, our HR pipelines are not 100% accurate. So there is some jitteriness in the activity predictions. Like take an example of watching TV while eating, right? So an HR pipeline can say that you are watching TV, eating, watching TV. For the similar instance, the pipeline can also result something like eating, eating, watching TV, and eating. Now, we use the temporal clustering approach to actually bring these similar looking activity patterns into the common representation. The way we do it is we start by getting the stream of activity patterns, and for a particular window, we generate the input representation, which is then converted into embedding space. The idea behind this embedding space is to actually bring the similar looking activity patterns together. Followed by this, we use a deep clustering network to cluster these embeddings and get the unlabeled clusters of activity patterns. These unlabeled clusters of activity patterns are then labeled as what context these patterns belong to using the TAO ontology. Okay, so to evaluate TAO, we use two different data sets, cases and extrasensory. So cases dataset has more set of sequential activities where activities are happening one over another. And for extrasensory, there are more interleaved and parallel activities. So we evaluate the ontology pipeline and temporal pipeline, and our approach in TAO to combine both of them, both the pipelines. So we can see that ontology has like 87% of accuracy with cases dataset because it's clean, it's sequential activities, but have really low accuracy with extrasensory dataset. At the same time, temporal pipeline has lower accuracy in some case, but perform at par across both cases and extrasensory. But with TAO's combined approach, we can get best of both worlds, and we perform at par in both sequential activities and parallel activities. We also compare TAO with baseline approaches. I'll quickly glance over it given the time constraints. But the idea is that TAO can detect richer set of context and performs at par across the contexts that are detected by baseline approaches. Okay, so using TAO's context detection pipeline, we prototype some wellness applications. One of the applications is productivity for office work. So usually in prior work, things like productivity or stress are evaluated using experience sampling or user surveys. But in our case, we do not ask any questions from users. Rather, we use the metrics that people have already derived using these experience sampling approaches and context detection from TAO to actually create these prototype applications. Few of the things that we use are like frequency of short-term breaks or length of focused work sessions. Similarly, for another application is physical stress in day-to-day life, which is based on factors like absence of physical activity and patterns of working hours. So let's look at some interesting user behavior patterns on extrasensory data set using our prototype productivity application. We can see that for this one user, you have high productivity during the first part of the week, and then low productivity, and then high productivity. In comparison, this other user has low productivity across throughout the week. And then some more patterns. So understanding these patterns can actually help understand what are the best intervention strategies to enhance user wellness. Similarly, you can see some patterns across users' physical stress. In conclusion, with TAO, we present a context detection pipeline that is agnostic to the HR streams used for activity predictions, and in turn can be used to build wellness applications. Our tool is open source, and you all are most welcome to look at it. Thank you.
Yeah, thanks for this great talk. So I have a question. What if there are some micro activities which can be performed in varied context? And what if there is an user who is transitioning between these activities, like writing, speaking, and then switch to writing? So in those cases, do you have any direction for future work? How to handle those cases?
Yes, thank you for that question. That's a very interesting question. So the way we handle that with TAO in temporal pipeline is the prominent activity clusters that you get are the patterns that are being repeated, which is usually higher than number of transitions between two activities. But yes, there is always a scope of future work where we can actually differentiate clearly what are the transitions and the actual context.
I guess we're missing a speaker. Okay.